Okay, so for you, I have in this week I have planned that guest lecture. Okay, so it's my request you try to fetch as much as knowledge that you can from that resource person. Okay, he's a basically industrial person. He runs his own industry regarding VLSI, and she has actually about 9 years of industrial experience, right, in the field of VLSI, then machine learning and AI, artificial intelligence, etc. Okay, so it will be very helpful and very what we can say, the knowledge sharing session for you. Okay, your attentiveness and alertness is expected from my side. Okay, he will explain unit number 4, that is state machine, then some of the basics of again VHDL programming. That means some of the basics belong from unit number first. Then he will start with unit number fourth. Okay, and thereafter there will be a kind of question answer session. So you can ask that person questions that you are facing related to this subject. Okay, so that will be helpful for you. Understood? Oh,
Yes.
okay, so um, we will continue our revision session for unit number 2. Okay, so now first tell me, just a part of revision, I will ask you one thing. So I have made you clear about how to identify which style of modeling that uh, we are using, or you are finding in particular program. Okay, so tell me now, on what basis you can able to understand, or you can able to uh, understand that whether it is a behavioral style modeling, whether it is a data flow style modeling, or whether it is a structural style modeling. Okay, so there are some what we can say particular formats, particular loop statements, right, particular concurrent statements, sequential statement that are used in different styles of modeling. Okay, and based on that we can decide or we can identify which style of modeling it is. Okay, so just tell me how you can identify whether it is a behavioral style of modeling. Okay, can anyone, or how you will come to know it is a behavioral style of modeling? Can anyone? Yesterday also I discussed the same thing with you. Can anyone? How you can come to know? By simply looking to any program, how you could understand that whether this is a behavioral style, or whether this is a structural style, or whether this is a data flow style modeling? How you can identify that? Yesterday I told you the same thing. Can anyone?
If your statement and process statements are used in behavioral step modeling.
Very right, very right. Normally, else if else, if then, okay, process statement, right? These are the four major statements that are used in behavioral style of modeling. Okay, then what about data flow style of modeling? What about data flow style of modeling?
Boolean expressions are used.
Very right. Boolean equations you can use. Okay, that you have derived from the KMAF analysis. Boolean equation can be used in data flow style of modeling. Next, when statement, when then statement, right? Case statement, select statement. Okay, in even behavioral model also you can use case and select statement. But the speciality of data flow modeling is when statement, when else, when then statement. Okay, so these are the particular statements that are being used in data flow style of modeling. Okay, and what about the structural style of modeling? What about the structural style of modeling?
When we are splitting the program
Hmm?
to half part instead of writing full program, that time structural statements are.
Very right, very right. In normally structural style of modeling, we are splitting our design. We are splitting our entire design into a small parts or small structures. Okay, and with the help of different port mapping statement, we are actually concatenating that small parts to form the entire design. बरोबर आहे. म्हणजे फॉर एक्झाम्पल full adder you can write direct code for the full adder also, that is also right. But with the help of structural style of modeling, you can write a half adder code, right? That means the two half adder followed by the OR gate that will form the full adder. That means in that case you have to write the two structural codes for the two half adders. Okay, then give its outputs to the OR gate, and whatever the final output coming out of your OR gate will be the or and of course carry. That carry part you have to take care. So that entire full adder followed by the OR gate can form the sorry, two half adder followed by the OR gate can form the full adder. Clear with this? So that is a structural style of modeling. Okay, so don't forget this thing because it's a basic of VHDL programming. Okay, so at least you must know which style of modeling that uh, the programmer is using in any program. Okay, so you have to take care of that and remember this thing. Okay, the same thing the same thing about the signal and variables that I discussed you in yesterday's lecture. What I had discussed you in VHDL programming, signal you have to define before the process, right? Always the signals you have to define before the process, and as it is a globally used, you can pass that same signal outside the process also, right, for the further use. But you cannot do the same thing with variable. Variable you have to define after process, and you or that variable value should not pass outside the process. तेच व्हेरिएबल तुम्ही प्रोसेसच्या बाहेर नाही यूज करू शकत, बट सिग्नल करू शकता. पण सिग्नलसाठी कंडिशन काय, तो प्रोसेसच्या आधी डिफाईन करायचा आणि प्रोसेसच्या बाहेर यूज करू शकता. व्हेरिएबलसाठी कंडिशन काय, तो प्रोसेसच्या नंतर डिफाईन करायचा आणि प्रोसेसमध्येच यूज करायचा, प्रोसेसच्या बाहेर यूज करायचा नाही. सो these are the some basic rules of the VHDL programming that you have to understand. Okay, so now we will talk about the VHDL code for 4-bit ALU. Okay, arithmetic and logical unit. Then this is a functional diagram of the ALU, arithmetic and logical unit. Okay, so what is the basic functionality of this arithmetic and logical unit? What is the basic functionality of this arithmetic and logical unit? Or why we are using the, or why we require ALU, arithmetic and logical unit? Don't you know this much simple thing? I guess you have learned these things in, and now in microcontroller also you are actually going through the same thing, I guess. Arithmetic and logical unit. Why
To
we are using
perform the
that?
arithmetic operations and logical
Yeah,
operations.
very right, very right. The simple answer is we require ALU to perform different arithmetics and logical operations. Right. Now, what kind of arithmetic and what kind of logical operations it can perform? Anything, okay? Depending upon your application. It can perform ORing, ANDing, right? NAND, NOR, XOR, right? NOT. These are the different logical operations that can be performed by the ALU along with the arithmetic operations. For example, division, increment by 1, decrement by 1, okay, multiplication of two numbers. These are the different arithmetic operations that you can perform using ALU. Okay, so now this is a 4-bit ALU that I have selected here. Okay, it has two inputs, A and B. Each input is of 4-bit, right? Two inputs, each input is of 4-bit. Now tell me, to what we can say, select the how many select lines that you can require. So depending upon how many operations that you are going to perform, depending upon that you can choose the select line. So here I am performing the 8 operations that ALU must perform. Okay, so 8, that means 2 raised to 3. So to choose that 8 operations you require a 3 select pins. Okay, similarly, suppose if I have selected here only 4 operations, how many select pins that you will require? Or how many yes, select pins that you will require for 4 operations only, just 4 operations? 2, right? With the help of 2 select pin, let's see what is job of select pin. To select particular operation, you have input with you, you have to just choose the operation that you want to perform with that input. For that purpose we require a select pin. बरोबर आहे. सिलेक्ट पिनचं काम काय, की ते कुठलं ऑपरेशन करायचं आहे, राईट, ते ठरवण्यासाठी आपण सिलेक्ट पिन यूज करतोय. मग इथे जर का तुम्ही 4 ऑपरेशन कन्सिडर केली तर तुम्हाला 2 सिलेक्ट पिन सफिशियंट आहेत टू सिलेक्ट द 4 ऑपरेशन. if you want your ALU to perform say 16 operations, then 4-bit select pin you require, right? 16 combinations, one combination for one operation. Likewise, you can choose the select pin input depending upon how many operations you want to perform. Here I have chosen say 8 operations, so I require a 3-bit select pin. Okay, so these are the different operation. And again, while explaining this program, I have actually told you, okay, this particular 3 sequence of operation is not fixed. You can change the sequence, you can add new operation, doesn't matter. कळलं का? म्हणजे इथं 000 ला A प्लस B केलं पाहिजे असं काही नाहीये, तुम्ही काही देऊ शकता ऍज यू विश. ओके, फक्त तुम्हाला 8 ऑपरेशन सिलेक्ट करायचे, दॅट टू बी अरिथमेटिक अँड लॉजिकल. You can choose any operation. Okay, and sequence also, it is not fixed one, you can vary that sequence, no problem. Okay, and of course as you have 4-bit inputs, so you will get the 4-bit outputs. So this is a typical block diagram of ALU. Okay, and here again I will repeat, uh, I have chosen the 8 operations, so I will require a 3 I will require a 3-bit inputs. Okay, here should be 0 down to 2, that means 3-bit. 3 should not be there, 0 down to 2, that means 3 bit. Okay, that correction you can make 0 down to 2. Okay, so these are the different operations and the select inputs I have given here. Now we will discuss the VHDL code for the same. So now this is the VHDL code for arithmetic and logical unit. So again, same thing will repeat. This is the library part. Okay, library is IEEE, the same library we are using in VHDL. You go for any code, library will be IEEE only. Packages, yes, you can add or delete the packages depending upon your requirement. So again, here I am using standard logic 1164 package. In that package dot all, that means all item we are selecting. Again, use this numeric.std package. In that package, again I am selecting dot all, right? All items. This is the entity part. Okay, entity ALU. This is the entity name I have given. A is the first input. Of course, it is of 4-bit. B is the second input. Of course, again it is also of 4-bit. Then select, it is of 3-bit, that is 2 down to 0. And again output, it is of 4-bit. Okay, so this is the entity part. Now this is the architecture part. So here actually we are using the process statement with case statement. Okay, process statement with case statement. And as we are using here a process statement, so obviously style of modeling is behavior. Okay, now first we will use the case statement. Case select is. Okay, then when 0 0 0, then output will get A plus B. Means what? When this select line is 0 0 0, case select is means what? Which parameter is to select? So select line. Okay, and what are the different combinations of that select line that we are mentioning here? Okay, now when 0 0 0 means who is 0 0 0? The select pin is 0 0 0. Then output will get A plus B. That means we are performing addition here. Addition of these two inputs A and B, whatever you want to give. Okay. Then when 0 0 1, the second case of this select line, then you will get A minus B. That means A subtracted from the B. Then 0 1 0, then you will get A minus 1. That means A decremented by 1. 0 1 1, A plus 1. That means A incremented by 1. Then 1 0 0 will be A and B, ending operation between the two inputs. 1 0 1 will be the A or B, ORing operation between the two inputs. 1 1 0 will be the not of A, right? Whatever the value of A, it will simply give the complement of that value, that is not of A. And for 1 1 1, you will get the A XOR B. That means your simple XOR operation. And when others, it will be simple, it will give the null value, right? End case, end process, and behavioral. Okay, so this is what the simple program of ALU, arithmetic and logical unit. Understood? सगळ्यांना समजला का? Everyone understood this? Okay, fine. Okay, now anything else that you want to repeat? युनिट 2 मधला अजून काही कुठला प्रोग्राम किंवा काही पार्ट कळला नाहीये? यू कॅन आस्क मी राईट नाउ. आय विल रिपीट इट फॉर यू. एव्हरीवन अंडरस्टूड? सगळ्यांना समजलंय? सगळ्यांना समजलंय का?
Yes.
Today we will stop here. In next lecture actually I have uploaded that notes part in your study material related to unit number 3 PPT. I will upload within 10 minutes. You just check the link within 15 minutes. You can find the notes and PPT for unit number 3. Okay. So today you go through that. In tomorrow's lecture, we will go for the unit number 3. Okay. If something you have not understood in unit number 3, we can repeat it. Only that points. ठीक आहे. एक 15 मिनिटात तुम्ही ती स्टडी लिंक चेक करा. I have uploaded the material there. Okay. समजलंय का सगळ्यांना? Okay. And in this week only, we will plan for expert lecture for you. Okay, related to unit number 4. We will stop here. Okay, we will continue in next lecture.